Do y'all know scientific notation? How to use it? So we'll go over a little bit more scientific notation later. I don't know why it includes just one paragraph over it in this PowerPoint. Today's lesson is going to be over significant figures, but always put the decimal after the first digit. But today's lesson is over significant figures. So all measurements are inaccurate. There is a precision of measuring device. So the precision of your measuring device determines how accurate or precise your answer will be. There's also human error. You may look at the measurement and not be able to read exactly what it is, or you might have misread the right number. Also, there's technique. So how you actually take the measurement depends on how accurate your value is. So if I were to take a ruler, go over to one side, measure it, and then when I'm walking over to look at the other side, I move the ruler around. I've introduced an error because the ruler is no longer positioned correctly. So what are your significant figures? Any non-zero digit is significant. So 1 through 9 are significant. Out of curiosity, who put example 1, 2, 3, 4, 5, 6, 7, 8, 9? You should know 1 through 9 are non-zero or digits. And do y'all know the name of our numbers? We use the Arabic numbers. We use the Latin alphabet. Anyway, zeros between non-zero digits are always significant. So, for example, the 0 between the 6 and the 6 is significant. Also, the 3 and the 2 6s are significant, and the 0 between the two zeros are significant. So the number 3,606 would have 4 significant figures. Zeros that indicate the decimal point are not significant, meaning that if it's to the left of the decimal point and there's no decimal point there, those zeros are not significant. So 360,600 only has 4. The last 2 are only there to indicate its position, that this is 360,600 and not 3,606. So those 2 zeros were only added to indicate where the decimal point should go. Zeros following a decimal point are significant. So if you see a 0 after the decimal, trailing zeros, I would put that word, trailing zeros following, meaning coming to the right of the number, are significant. So 3.60 would have 3 significant figures, but 3.6 has 2. Zeros appearing before a non-zero digit are not significant. So any of the zeros that come before a non-zero digit are not significant. So 0.00009 only has one significant figure, so 0.0009. They're called leading zeros. They lead the first digit, the first non-zero digit. They are not significant. So as I stated, significant figures in a measurement include all the digits that are known precisely, plus one last digit that is estimated. Again, you only include one digit to be estimated. The rest of the digits are known precisely. Always put the zero in front of a decimal point. Whoever did not get onto you in elementary for leaving off the zero, I have opinions about them. You should always include the zero in front of a number or a decimal point. It should be 0.873, not 0.873. One of the primary reasons for this is if you are writing a sentence and you don't know if that period is supposed to be the end of the previous sentence or part of the number. And it's also hard to see that this is going to be a fraction of equivalently a number less than 1. Sometimes you don't see the point in front of the number. So how many significant figures are in problem 1? One. So we don't include the trailing zeros. What about number 2? So when doing these problems, what I suggest so we have 200. We have 200.0. Identify the first significant digit and then identify the last significant digit. How many? Then count how many digits are between. So we always include zeros after the decimal point unless they are leading zeros. So here would be 4. What about number 3? So number 3, we do not include leading zeros. So let me do this. So we have 3 is 0.001. So this is our first significant digit, the first non-zero we encounter. We do not include any digits, any zero digits that come before it. So this has exactly 1. We use this notation to indicate, we usually do that at least. We put parentheses around it saying that this has 1 significant digit. Number 4, 218 has how many? 3. 5, 320. So 2. So we don't include trailing zeros unless they're after the decimal point. How many does 0.00530 have? So if it's after the 0 point, we include trailing zeros. So this would have 3. We don't include the zeros. Yes. Unless of course it's before the decimal. Learning significant figures, usually it's more of you learn by example. It's hard to explain, but once you see it over and over and over again, it's something that's easy to pick up. So in this case, we would not include the 0 because it's before the decimal. There is no decimal there. Here we would include it because these come after the decimal point. So we never include leading zeros. Leading zeros never include leading zeros. So 7 is 22,568. So 5. And number 8, 4,755.50. So it'd be 6. Because the 0 is trailing and it's after the decimal point, trailing means coming after digits, we would include it. Yeah, we don't include trailing zeros if they're before the decimal point. So if it's before the decimal point, or if the decimal point isn't there, so you should never. So I don't like doing this, but if I had done 320 dot, this would technically have 3 significant figures because there's a decimal point. If there's no decimal points, I'll write that. If there's no decimal point, don't include trailing zeros. If there is a decimal point, include trailing zeros. And I think that can almost summarize your rules. Never include leading zeros. If there's no decimal points, do not include trailing zeros. And if there is a decimal point, include trailing zeros. And all zeros between non-zero digits So include all zeros between non-zero digits, and of course include all non-zero digits. That's probably a better explanation. So always include non-zero digits, include all zeros between non-zero digits. Never include leading zeros, the zeros that come before a non-zero, and only include trailing zeros if there's a decimal point. 1 through 9. 1, 2, 3, 4, 5, 6. Everything not a zero. Does that make sense? Everyone good? For science, if it's written in scientific notation, we only look at the first number. So 4.0 times 10 to the 3, we only look at the 4.0. We ignore times 10 to the whatever. So how many significant digits are in number 1? 2. What about number 2? 3. What about number 3? 1. Number 4? 3. So we include the trailing zeros at the end because there's a decimal point. What about number 5? 6. Again, there's a decimal point, so we include trailing zeros. What about number 6? 22,000. 2. So there's no decimal point. We do not include trailing zeros. Number 7. Yeah, 4. So if the zero is in between two non-zeros, I like scanning it and looking at a range of values. So coming back to this, here, and then there's no digits after. Here, no digits after. Here, this is no decimal point, so I don't include it. There is a decimal point, so I include the 0. You'll notice that all the significant digits are grouped together. So looking at, let's say, this example, 100,001. Yes, it'd be 6. So we would include all the zeros between the non-digits. So this is your start, this is your end. We'd include this. So that would have 6. Let's do this. 101,000 would have how many? It'd have 3. So again, we're looking at this range of significant figures. And then if I did 101,000.0, seven. So we have the definitions wording, but again we're looking at a range of values. So this is our first one, and we have to include this 0 because it is after a decimal, or includes a decimal point. So we would go all the way down here. So there's 1, 2, 3, 4, 5, 6, 7. So number 7 was 4, and 8 is 2. If you add or subtract, the answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. I don't like how they're wording it with number of decimal places. Alright, let's see. If you add or subtract, the answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. I really don't like this term. They're using number of decimal places to mean significant figures. I think this is supposed to say if you add or subtract, the answer is rounded to the same number of significant figures as the measurement with the least number of significant figures. Yes, I believe you should change number of decimal places to significant figures. Yes. Um. Here's the reason for this. Let's say that I have approximately 10,000 pounds of cow feed. If I add 1 gram of cow feed to it, I didn't know precisely how many. I only knew that it's around 10,000 pounds. So so here, I only do grams. Do it that way. So if I have approximately 10,000 grams, so if I have approximately 10,000 grams, and I add 1 gram to it, I still have approximately 10,000 grams. The reason for this is because I had no clue exactly how much I had to begin with, right? If I just went and eyeballed it, I could have had somewhere between 9,500 grams to maybe 10,500 grams. So this, because I'm uncertain in the first digit, I don't know how precise my answer should be. So if I say that I'm adding 1 gram to it, I might be adding it to 9,501 grams, or I could be having something like that. So if you do not know precisely how much you started out with, you can't make the number more precise than your least least precise number. Does that make sense? Now then, if I knew that I had, for example, 10,001 grams, so this tells me I'm somewhere accurate around 1 gram. And let's say that I added to this 1.0001 grams. This is where the decimal places. I mean, it's hard to explain. I'm not going to be grading you too much on adding and subtracting and multiplying. I'm going to throw away significant figures for the rest of the year after some point. But it's very important in college that you know significant figures because they'll test you more over it. But obviously, if I only know that it's somewhere around 1 gram accuracy, this is way too much information. So this would add to 0.02 grams. So I guess I told y'all wrong. It would be number of digits. It would be decimal place. I'm sorry for the confusion, but because it's worded slightly wrong. So it says number of decimal places. What number of decimal places is meaning is if I were to draw a line right here, this is the decimal place. Everything to the right of it doesn't matter. And you would have to round this number. So let me do another example. So if you had 10,001 grams plus 1.5 grams, what you should do is round this to the same number of decimal places. So that would be 10,001 plus 2 grams, and that would be 3 grams. That's what you're supposed to do. Hopefully I didn't confuse y'all too much. Again, this is best done by practice and working on it. So for example, let's say that we have 1,000 or 11,230 grams, and I added to it 12 grams. I wouldn't say you don't even have to round. Just add this together, and then look at where the least significant decimal place was. So the decimal place where it's not really a decimal place, it's where because there's no decimal. There's whatever digit is least. There's a 0 here. So this one only had 4 significant digits. So I need to put my answer and round it to here. So 11,230 grams plus 12 grams. It's only accurate to right here. Yes. Let's do 1,360 grams plus 17 grams. So that would be 1,377 grams. But it's only accurate to right here. So I would round this to 1,380 grams. Would be my answer. Yes, you always round it to whatever place is most accurate. So another example. 1,555 grams plus 100 grams. So that would be 1,655 grams. But look, these are non-significant zeros. They're trailing zeros. So it's only accurate to this spot. So I'd round this to 1,700 grams. So 1,555 grams plus 100 grams. I would need to round it to this number of significant digits. Because again, this number means that I'm adding somewhere between 90 grams to 110 grams. I'm only certain about this in one spot. I do not know how precise this number is. It could even be much worse than that. This could be anywhere. This number could be 0. That digit could be 0, so it could be 0 grams I'm adding. Or that digit could be 200 grams. I could be off by one because the last digit, the last non-zero digit, the last significant figure is estimated. I estimated it as about 100 grams. So so as you're taking numbers, and the more uncertain you are on the value, the more uncertain you are on the final answer, right? So if you were to go and I ask you to do a ratio, get 5 grams of this, 7 grams of this, and and you went and you put 5 grams, measured it out, and you went, I'll estimate this. It seems just to be like a dash, and you added a dash. You don't know how many total grams you have now, right? Because you've lost, and this notation treats it that we only know this is accurate to 2 decimal spots, 2 digits. if you multiply or divide two numbers, the answer is rounded off to the number of significant figures, and the least precise term used in the calculation. So its multiplication and division is based on significant figures. That's where I was getting confused from earlier. So when you multiply and divide, it's based on significant figures. So adding and subtracting is based on the position of the least significant figure, or the decimal place, or decimal digit. I don't like the wording of it. It's wherever the least significant digit is, that line I was making. We'll work on some examples here. Yes. Everyone good? So let's do some examples. So 1.35 meters times 2.467 meters. Plugging that in the calculator, I get an answer of 3.33045 meters. So we need to round it to the appropriate number of significant figures. This one has 3. This one has 4. According to our multiplication, our division rule, when we multiply, we choose the least. So this one should only have 3. So we round it to 3 significant figures, and that is our answer. So if I did 1,035 square meters divided by 42 meters, that is equal to 24.642857 meters. So again, this one has 4. This one has 2. We need to round this to 2. So that would be 25 meters. At 2. I wouldn't do the rounding until the very end. So doing the next one, 12.01 milliliters, 35.2, it'd be plus, but there's 3 numbers, and 6 milliliters. So adding that together is 53.21 milliliters. And notice how I made it vertical. So I look at the least spot. So this one is the least spot. So I would cut it off and throw away everything after that. So that is 53 milliliters. So for addition, we look at whichever column has the last point. So this one had nothing after the decimal, so we would cut it off on one spot. Make sense? So we cut it off on what spot it is for addition and subtraction. So 55.46 grams minus 28.9 grams is 26.56 grams. So it is we would cut it off on this because there's nothing here. So, and then we have to round, so that'd be 26.6 grams. Would be how you would record your answer. So 0.021 centimeters, 3.2 centimeters, and 100.1 centimeters, all multiplied together. You would get an answer of 6.72672 cubic centimeters. And for multiplication, we count significant digits. That has 2, this has 2, that has 4. So we would write our answer with only 2 significant digits. So another example, 0.15 centimeters plus 1.15 centimeters plus 2.051 centimeters. That would be 3.351 centimeters, but we would cut it off on this spot. So 3.35 centimeters. So 150 liters divided by 4 liters is equal to 37.5 liters. This has 1 liter, 1 significant figure. This has 2. So we need to write our answer with only 1 significant figure, which would be what? 40. Is this making sense? I'll do a few more examples. I only got 3 left. 505 kilograms minus 450.25 kilograms, which would be 54.75 kilograms. But we're only precise to the ones place. This is subtraction, so I would round this to 55 kilograms. Bless you. 1.252 millimeters, 0.115 millimeters, 0.012 millimeters. All this is being multiplied. That'd be equal to 0.001727776 millimeters. This has 2 spots, has 3 significant figures. This has 4. We choose this one. And so we would round this to 0.0017. And this would be cubic millimeters. Last example. So doing scientific notation, 1.278 times 10 to the 3rd power meters divided by 1.4267 times 10 squared meters. You can either put your answer in scientific notation. So in scientific notation, it would be 8.95773 times 10 to the 0. There won't be any units because meters and meters cancel out. So this has 1, 2, 3, 4, 5. That has 4. So we would only write the answer as 8.958. Make sure you round correctly. Times 10 to the 0. Yes, for scientific notation, you ignore the times 10 to the this is a ratio. So you can this doesn't have units because it's a ratio. If I say something is twice as long as the other one, so 2 feet is twice as long as 1 feet. 1 foot, right? So 2 feet divided by 1 foot is just 2. There is no feet on it. There's no units on it. So that would be the example of comparing a ratio between 2 things. So if there's no questions, give y'all homework. Why would I not give any? Why would I give y'all something over the weekend that's not 3 days long? No, it should be very simple. I thought today's lesson was going to actually be very short and you can do it in class. Do note that the bottom of the piece of paper is just a duplicate. Is only the top half. Yeah, so you can put an X on the bottom portion. Miss Anglin liked cutting this out. I don't use the journals.